We believe that the James Webb Space Telescope will track down a ton of intriguing things. We believe that the James Webb Telescope quite recently tracked down something astonishing that is shaking the very underpinnings of what we know about the universe. We no longer understand how the universe works in light of this finding. As researchers update their theories, they uncover hidden infinite secrets and see universes that are beyond our most stunning dreams. The Webb Space Telescope's most recent discovery has the scientific community ablaze with excitement. With every observation, this cutting-edge telescope takes us back in time and reveals new information about how the world came to be. What sort of colossal discovery has Webb recently made? How will this new information significantly impact the way we think about the universe and its secrets? Let's find out. One of the most significant features of the Webb telescope is its ability to look far into the past, showing us the first stars and galaxies being formed. It helps researchers take a good look at the atmospheres of exoplanets, where life could potentially exist, and at the strange properties of black holes scattered across the universe. Black holes are mysterious, infinite forces created when stars explode. Their gravitational pull is so strong that not even light can escape. When an event horizon reaches a black hole, it alters the fabric of spacetime. This region, known as the event horizon, is the point of no return and defies the rules of modern physics. Although black holes are relatively new as a concept, the theory of relativity provided clues about their existence long before they were actually discovered. The theory states that spacetime can be warped by masses dense enough to create the strange shapes we call black holes. Black holes were once invisible, but their natural gravitational pull on the matter around them makes them detectable. Various advanced technologies are used by space satellites, especially the Webb telescope, to track clear signs of black holes. Researchers can determine what a black hole is and how it functions by observing the behavior of stars and gas around it. Specifically, they study how stars close to a black hole are affected by its gravity, observing whether they orbit or are pulled by its strong gravitational forces. With its cutting-edge tools and unique features, the James Webb Space Telescope significantly helps us delve deeper into the universe to find answers to questions once thought unsolvable. For example, a black hole and a nearby star emit high-energy radiation as they get closer, making the surrounding space in the universe extremely bright. Despite their profound impact on nearby matter, black holes have an enigmatic quality. The theory of relativity does not specify how to measure their dimensions because anything that gets too close to a black hole is destroyed by its strong gravitational pull. That's no-hair theorem enhances our understanding of black holes, asserting that they have only three measurable properties: mass, electric charge, and angular momentum. Once stabilized, black holes are simple, but their complexity is hidden within this simplicity. For this reason, it is challenging to differentiate between black holes, even if they share the same physical properties. By examining various types of black holes, we can see that they form a vast family with many unique characteristics. The smallest type of black holes, called stellar mass black holes, have masses between 1 and 100 times that of the Sun. On the other end of the spectrum are supermassive black holes, with masses millions or even billions of times greater than the Sun's. Scientists believe that supermassive black holes, with more than 1,000 times the Sun's mass, were formed from the deaths of giant stars in the early universe. There are also intermediate black holes, which fall between stellar mass and supermassive black holes. Unlike popular belief, some black holes are incredibly small, almost as small as an atom. It's hard to imagine or believe that supermassive stars can shrink to such sizes while retaining such enormous mass, far greater than an entire mountain. Yet, this is the reality. As you observe the Milky Way, you'll notice the universe is filled with black holes, each with masses of millions of solar masses. Massive black holes often remain at the centers of galaxies, including our own Milky Way. This idea is based on both theory and observation. Sagittarius A*, for example, is a giant black hole at the center of the Milky Way. With a mass equivalent to about 4 million suns, it is the largest object in its vicinity. Scientists have been fascinated by black holes for decades due to their complexity, which has spurred more and more studies. Black holes enable the testing of various concepts rooted in general relativity and quantum mechanics, pushing physicists to explore new realms of physics. These studies challenge our current understanding of the universe, testing its validity. The more we learn about black holes, the better we understand them. As technology and observation methods improve, our comprehension of these celestial phenomena continues to expand. However, we do not yet fully grasp black holes because we cannot directly observe them. Stellar mass black holes, for example, reach extremely high temperatures, billions of Kelvin, so their study must often be done indirectly using theoretical models and indirect observation techniques. As previously mentioned, the event horizon makes black holes so intriguing. It is a boundary in space-time where nothing, not even light, can escape. This fundamental characteristic of black holes represents more than just a massive force with strong gravity. It underscores the mystery and profound nature of these cosmic phenomena. Gravitational force is a piece of reality that we can't completely comprehend. At the point when we draw near to the event horizon, the principles of physics change amazingly, yet they still give us a glimpse into the mysteries of these phenomena. We know for sure how some of these black holes come to be. A certain reality is that black holes often form when stars fall apart due to gravity. This happens when an object's own weight becomes too much for its internal pressure to hold it up against gravity. Researchers emphasize how important high-density regions are for this collapse. In this era of the universe, such densities are generally found in stars. However, in the early universe, after the Big Bang, densities were much higher, which probably made it easier for black holes to form. To create a black hole, the mass must not only be extremely dense but also spread out randomly so that it doesn't become uniform. For primordial black holes to form in such dense regions, the density must have varied at the beginning, allowing the black holes to grow through gravity. However, gravitational collapse isn't the only way black holes are created. High-energy collisions can also create black holes if they get dense enough. As of 2022, mass imbalances in particle accelerator experiments have not directly or indirectly shown that this has happened. There are many fascinating things about black holes, but the most intriguing is how they change over time. They don't have fixed sizes, and by consuming the matter around them, they can continue to grow endlessly. To sustain themselves, all black holes consume gas and dust from space, which causes them to grow dramatically. Another significant factor that makes some extremely large black holes possible is this same process. It has also been suggested that this mechanism could explain how intermediate black holes form in globular clusters. Black holes can also merge with other celestial objects, such as stars or even other black holes, to create a supermassive black hole. The evolution of black holes is still being studied. Now that the James Webb Space Telescope is operational, we will be able to uncover even more. There have been concerns that a black hole could collide with Earth and destroy it, but these fears are unfounded. Experts have proven that this cannot happen. Even if the Sun were replaced by a black hole of the same mass, Earth would continue orbiting it as it does now because their gravitational pulls would be identical. Moreover, black holes don't roam the universe devouring celestial bodies like planets, moons, and stars. For this reason, the galaxy as a whole would not be destroyed by a black hole, as none are near our solar system. Additionally, the Sun cannot become a black hole because it doesn't have enough mass to collapse under its own gravity. Returning to the James Webb Telescope, scientists using this incredible instrument have recently made an astounding discovery that is shaking our understanding of the universe to its core. What enormous, strange thing did they find in the depths of space? We'll have to wait for more information about this finding, which is changing everything we thought we knew about the universe. This cutting-edge device, the James Webb Space Telescope, not only observes nearby celestial objects but also discovers remnants from the distant past. About 400 previously unknown objects in the near vicinity of our solar system have been identified. This milestone excites the scientific community, demonstrating how much the telescope has expanded our knowledge of the universe. Remember, Earth, stars, and galaxies make up only about 5% of the universe. There are likely countless other possibilities hidden deep within the cosmos that we have yet to understand. This is the reality as we know it. The James Webb Space Telescope is a powerful tool that is reshaping our understanding of space, revealing its secrets one by one. The Webb marks the beginning of a new era in space exploration. It allows us to study mysteries beyond our wildest dreams. Not only has it discovered countless peculiar phenomena in the dark, uncharted 95% of the universe, but it has also shown us how our cosmos has evolved over time. Many events in the universe remain enigmatic, hidden in the darkness of the sky. This is why it is crucial to uncover the mysteries of the cosmos and the laws governing it. The James Webb Telescope acts like a time machine, enabling us to look back and witness the universe from the dawn of light to the birth of galaxies. As research continues, a remarkable discovery has transformed how we perceive the universe. The telescope revealed numerous ancient galaxies that formed only 600 million years after the Big Bang. The Advanced Deep Extragalactic Survey program on the James Webb Space Telescope, affectionately called JADES, plays a key role in this important finding. The JADES project provides the data necessary to understand the early stages of star and galaxy formation. With today's technology, the Webb telescope continues to reshape our perspective and demonstrate the vastness of the universe, unraveling the mysteries of reality that have been hidden. Scientists have dedicated extensive time to using the space telescope to carefully analyze and classify faint, distant galaxies. A graduate student at the University of Texas at Austin, named Ryan Ensley, was a key member of this team. His primary focus is on galaxies that existed in the early universe, approximately 500 million years after the Big Bang. 800 million years after the huge explosion, this time was known as the Epoch of Reionization by specialists. According to Ennis and other researchers' findings, the universe was shrouded in a confused state of gas just after the enormous detonation for a long time. This made it incomprehensible for strong light to travel. Around 1 billion years after the enormous detonation, this fog cleared, revealing darkness. This was the beginning of vast transparency, otherwise known as reionization. Many scientists thought that this time of transition could have been caused by active, very massive black holes or galaxies filled with hot, young stars. Ensley and his associates used the near-infrared spectrograph device as part of the JADES program to study these galaxies. The goal of their work was to find signs of star formation, which led to astounding discoveries. Interestingly, almost all of the galaxies they studied had emission line markers that were much stronger than usual. This is an obvious indicator that new stars had been forming recently. Ennis stated that the main source of the heat required for these processes came from the supernova explosions of the very large, early stars. The study also found that the birth of stars in these young galaxies followed a pattern of long periods of strong star formation, interrupted by brief times of ionization during which starbirth activity dropped significantly. Most likely, massive stars quickly ran out of fuel and exploded as supernovae. These explosions probably poured energy into their surroundings, making it possible for gas to condense and form new stars during quieter periods. As we learn more about how the universe evolved, the JADES program is taking the lead by capturing a wide array of galaxies that existed less than 1 billion years after the Big Bang, when the universe was still very young. The primary goal of this study is to help us understand how stars formed in the first few thousand years after the Big Bang. The light from these galaxies changes as it travels through the expanding universe. Although they are extremely far away, the light stretches into longer wavelengths, making it appear redder, a phenomenon known as redshift. Redshift allows cosmologists to estimate how far away galaxies are. It can also be used to identify galaxies that formed very early in the universe. Previously, our studies were limited to a few dozen galaxies with a redshift greater than 8. A redshift of 8 means the universe was less than 650 million years old at the time. The JADES program, however, has completely transformed our capabilities. It has enabled us to discover almost 1,000 of these extremely distant galaxies. Researchers typically determine a galaxy's spectrum by analyzing its brightness at several closely spaced frequencies. Alternatively, they use imaging filters that isolate specific bands of colors. This method provides multiple brightness ratios simultaneously, simplifying the process of estimating galaxy distances. This technique has proven highly effective, allowing scientists to gain crucial insights into the universe. The mysteries of space are gradually being solved, thanks to cutting-edge technologies and programs like JADES, offering a unique glimpse into the earliest stages of our universe's formation. Notably, Eni was not the only researcher involved in this project. Kevin Harrington from the University of Arizona in Tucson also utilized the near-infrared spectrograph. Their findings identified over 700 active galaxies that existed between 300 and 650 million years after the Big Bang, based on photometric redshifts. The global academic community was astonished by this new data. The sheer number of these galaxies was far greater than previously expected, fundamentally challenging earlier assumptions. Before the launch of the James Webb Space Telescope, JWST, scientists knew very little about the evolution of these distant galaxies. The JWST has broken new ground, uncovering sites the Hubble telescope could not previously detect. It has revealed new objects, exoplanets, and phenomena, including possible signs of life. The quest for extraterrestrial life has gained momentum, as scientists now focus on planets like Proxima Centauri b, also called Alpha Centauri bb. Proxima Centauri b, part of the Alpha Centauri triple star system, is the closest exoplanet to Earth. Orbiting its red dwarf host star at 7.5 million kilometers, it completes its orbit in just 11.2 Earth days. This Earth-like planet has a radius slightly larger than Earth's and a mass of at least 1.07 times Earth's. Despite its location in the habitable zone, evidence of an atmosphere is still scarce. The host star, Proxima Centauri, is a flare star, emitting strong electromagnetic radiation that could strip away planetary atmospheres. The pursuit of answers continues, with researchers employing advanced models to understand the planet's evolution, heat retention, and rotation. Programs like Breakthrough Starshot aim to send robotic probes to study Proxima Centauri b. These initiatives could provide definitive evidence of life on this fascinating exoplanet. As we continue to explore the cosmos, Proxima Centauri b might emerge as a prime candidate for finding alien life. The journey of discovery has only just begun, and future observations promise even more groundbreaking revelations.